All right, let's look at multiplying radical expressions. So there are expressions like this that include some kind of radical. Five times the square root of 3 would be one. Um, and here's let's start with this. Actually, I'm just going to recreate this whole sequence here, so you get this point. Um, so when you multiply radical expressions, you multiply the thing outside of the um, radical. Like you'd go 5 times 4. Think of it as just combining like terms. 5 times 4 would be 20. And then you multiply the radicands, the things under the radical, so 3 times 27. So let's focus on that step there. That's kind of the more complicated step. And let's look at two simple radicands, 2 and 6. So say we got something times the square root of 2 times something times the square root of 6. Right, so you would just, so looking at the radical part of the expression, you do 2 times 6, so this would be equivalent to the square root of 12. But you're not done there, and this is kind of the slightly tricky part, but not too tricky. You're not done there. That's not, I mean, you could be done there, but you want to get it in its simplest form. Um, so, and here's why. I could split up 12 into, I could call that 4 times 3. So I could keep going. I could rewrite this as the square root of 4 times the square root of 3. So we had 2 times the square root of 6 is now equal to 4 times the square root of 3. Well, square root of 4, or square root of 4 times square root of 3. Square root of 4 is 2. So this would equal 2 times the square root of 3. Now that's as far as we can go. Alright? So be on the lookout for if there's a perfect square inside of the radical hiding in there, like 4. 4 can easily be square rooted, so that can be brought outside of the radical. 3 can't. The square root of 3 is just some weird decimal, right? So it's best just to leave it there. So just be on the lookout for that kind of thing. And even it could help to, if possible, to do a little bit of simplification beforehand. For example, okay, so we've got 5 times the square root of 3 times 4 times the square root of 27. I could go ahead and look at this as 9 times 3. Um, so the square root of 9 is 3, so I could bring that outside of the radical and make it a 3. So we've got 4 times 3 out front. So this would be 12 times the square root of 3. So we can go ahead and simplify that a little bit first to make our job easier later. Or you could do 3 times 27 and go from there. But I think it's easier just to start with simplifying a little bit there. So now we've got 5 times the 5 times 5 square root of 3 times 12 square root of 3. So that we do 5 times 12, which is 60, right? Times now we multiply the radicands. 3 times 3 is 9. Well, square root of 9 is 3. 3 times 3 is 9. And in general, if you've got, you're multiplying something with the same radicand, just, that's 3. Yeah, just think of it like that. In other words, square root of 3 times the square root of 3 would be equivalent to square root of 3 squared, a number times itself. And squaring something and square rooting something are inverse operations, so or inverse functions. So so that just becomes 3. Anyway, a little side note. Okay, so we've got 60 times the square root of 9, and the square root of 9 is 3. So this is 60 times 3, which is equal to 180. So we'd be done at that point. Let us try another one. 7 square root of 2 times 3 square root of 18. And let's we could simplify first. That'd probably be better, but I'll show you what it looks like when you don't. So 7 times 3 is 21, and 2 times 18 is 36. Actually, it's probably simpler to do it this way, actually. Square root of 36 is just 6, so 21 times 6, which would be, what is that, 126? Yeah. Alright, let's try another one. And this one's going to be more like kind of what I started with. Okay, so 6 square root of 3 times 5 square root of 15. We do 6 times 5 would be 30. And then 3 times 15 would be 45. Now, are we done? Not necessarily. If we can pull out a perfect square from this guy, it can be a little bit simpler. So, um, I'm looking at that, and I'm seeing you could have 3 times 15, which is what we just had. That doesn't really get us anywhere. And square root of 15 is not some kind of nice number. I could look at this as 5 times 9, or 9 times 5. Right? Because then the square root of 9 is 3. So I can pull that out front. So this would be equal to 30 times 3. And then what's left under the radical is 5. So 30 times 3 is 90. So this would be 90 times the square root of 5. So just look at the radicand, see if there's, if one of the factors of the radicand is a perfect square, something that you can, easily square root and get it out front, just to simplify things further. Alright, so I've got some practice problems for you. Don't panic at the x's. That's a little extra challenge for you. Just follow the same pattern that we've been doing. There's nothing extra that you need to know. You just need to apply what we've learned to these problems. Have fun. Alright, see you later.